Hey everybody, so let's get started. So we're going to talk about 11.1 today, which also kind of feeds into the 11.2 and the 11.3. These three sections are going to be pretty important for us over the next couple sections all the way to 11.5, just so you know. So 11.1, 11.2, 11.3, these are all about ways that we can count up a total number of possible outcomes to situations. Because what chapter 11 is about, it's all about probability. Okay. And you're going to be doing a lot of fraction work in the calculator. We're going to let the calculator do everything. Pretty much all of your answers are going to be fractions, which is why you need to make sure that you're definitely using this calculator, because my math lab wants your answers as fractions. Okay, so if you haven't worked with the calculator very much, let me pull that up real quick. Your best friend, your fraction keys are alpha, y equals. And right there are your fractions, and we're going to be using the number 1. Okay, so when you hit that, look, oh, it looks just like a fraction. So cool thing about this is once you know your numerator and denominator, which you'll get when you start working through things, your numerator, you just put in the number. When you're ready to go to the denominator, scroll down, put in your second number, say maybe it's 16, and then you hit enter, and look at that. The calculator will do all the reducing for you. So please, when it comes to these fractions, to make sure that you're good to go, let the calculator do the dancing for you, okay? Let the calculator do all the hard work. So all you do, again, your best friend, alpha, y equals, you want number 1, you just hit enter, and then you put in your numbers, 3 over 15, hit enter, and it reduces it for you. And that's the answer that they're going to be looking for in my math lab, is these reduced fractions. Okay, the other piece I want to show you that you're going to use a lot with 11.1 through 11.5 is under math, and you're going to scroll all the way over to the word prob. So you scroll using your little directional cues here, okay, and you want to be under prob, because we are in probability. That's what chapter 11 is all about. We're going to use 2, 3, and 4 here. The NPR, the NCR, and the exclamation mark. Okay? So we're going to be using those in this chapter, chapter 11. So math, scroll all the way over to prob. It's right up here at the top. It's right there. So scroll one more, and we're going to be using the NPR, the NCR, and the factorial. Okay? Those are going to be the big things that we want to use. All right? And our fraction key. So with that being said, let's do some fundamental counting principle, because that's what section 11.1 is all about. It's all about the fundamental counting principle. So here's what it is. Fundamental counting principle says if you can choose one item from a group of m items and a second item from a group of n items, then the total number of 2 item choices is m times n. And this can be expanded beyond 2 groups. Let me give you some examples of this. This is when you want to go to Sonic and you want to get a drink and then put all these extra flavorings in it. Okay, so like you get a Coke and you get a vanilla squirt in it, you get the cherry squirt in it. Okay, so you have all these different things that you can do. So you've got your base drinks, which are like Coke, Sprite, Pepsi, Dr. Pepper, whatever it is, Mr. Pibb. So you got those as your base, and then that's like a group M. Okay, that's like your first group. What's your base drink? And then you got all these flavors over here, like you can put cherry in it, grape in it, you can put vanilla in it, so on and so forth. And then maybe we have another group where my daughter, she likes to put gummy bears, or I don't know why. I mean, it's a drink. What, you're not going to drink gummy bears through a straw. So, but she put gummy bears or nerds in it. I know something. So you can have some like hard toppings in it, like gummy bears, nerds, whatever. My daughter's weird like that. So see how I had 3 groups there. I had the base group, I had my flavoring group, and then I had like a hard candy group at the end. And if I take however many base choices there are, that's M. However many flavor choices there are, that's N. And then however many hard candies I have, see I have 3 groups there, multiply all that together, that's how many different drinks I can come up with. Okay? That's what the fundamental counting principle is saying. And the same thing, like if you go to Boston Market, you kind of get the same thing. You get your base meal. You want meatloaf, the turkey, the chicken pot pie, whatever. And then you get to choose like 2 sides. Okay? So your first set of sides, you can choose anything you want. And then you have these second set of sides that you can choose anything you want from. And that's just like what we were talking about. Take all the base possibilities, your base meal, your main meal, take all those possibilities, however many they are, multiply that by however many opportunities there are for your first side, and then multiply that by however many opportunities you have for your second side, and that's how many choices you have that you can make. Okay? So that's all the fundamental counting principle is saying, is like you're going to pick from this group, you're going to pick from the second group, you're going to pick from the third group. And I want to know how many ways can we do that. Okay. Another example, every day when you get up, you have to choose some sort of top to wear. You have to choose some sort of bottoms to wear. You have to choose some sort of maybe shoes to wear. So again, you can expand that from like to socks too, and then the kind of undergarments you might want, like underwear and things like that, or boxers, whatever. And then you can be like, oh, I got to choose my earrings. So right there, I've got 6 different groups. I can choose earrings from my boxer briefs to underwear, whatever it is, to your socks, to your shoes, to your shirts, to your pants. Right there, 6 groups. I take all the amount of items I have in each one and multiply those together. I get how many different outfit choices I have in the morning. Okay? Again, fundamental counting principle is about. It's taking an item from each one of these different groups. Fundamental counting principle is all about choosing from all these different groups. Okay? And then you multiply all those choices together, and that's the total number of outcomes you have. All right? So let's do some. It's not hard. So if we look at this, it says the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? Okay, so this is just what I was talking about with Boston Market. Okay, you got a main meal. How many different main meals can you have? There are 14 of them. That's what I call that first group, that M. I have 14 choices for my main meal. And then I also get to choose from an appetizer. Okay? There are 6 of those. That's what I'm talking about with that group N. I have 6 choices for appetizers. Again, you get the same thing happens in real life to you when you go to Chili's, when you go to Applebee's, wherever it is. They offer that 3 for $10 kind of deal. Okay? So if I want to know how many meals I can have, all I have to do is take this 14 times the 6. All 11.1 is about multiplication of numbers. That's all you got to do. 14 times 6 gives us 84 2-course meals. Add 84 different options. And again, as I told you from chapter 9 to chapter 10, same thing's going to happen in chapter 11 and chapter 12. Labels come with everything. So here we're talking about 84 2-course meals, different 2-course meals to be specific. And that's it. Okay, that's the fundamental counting principle. That's all there is to it. There's no tricks or anything like that. This is it. Just take how many choices you have for group 1, how many choices you have for group 2, group 3, group 4, whatever, so on and so forth. And all you got to do is multiply those. So I got a couple more examples. I got like 5 more. Give them to you because I want you to experience different types of situations. And throughout this entire last module 3 in chapter 11 and chapter 12, I'm going to be throwing lots of different situations at you. So feel free as we go from, I will make sure that each example has a pause, and you pause the video, give it a shot, and then watch the video and see what happens. Okay, see how well you did. If you feel comfortable with it, you don't have to continue on with it. You can move on to the next video. It's your choice. So here, again, you have these notes in front of you. Hopefully you've downloaded them, looked at them. I've got 5 questions. Feel free to give each one a shot. I'm going to go ahead and pause the video now and take a look at these questions and go for it. Okay, so let's start with question 1. Get out of this so I can go back to my page with. So it says, a popular brand of pen is available in 9 colors and 5 writing tips. How many different choices of pens do you have? So with the pens, well, I've got colors and I've got writing tips. So there's your 2 groups, just like what we had before, the main course and the appetizers. Well, how many colors do I have? I have 9. I'll multiply that by, well, how many writing tips? I got 5. All I got to do is multiply those together, and I got 45 different pens. Done. That's it. That's all you got to do. That's all that happens. Okay? There's your answer. All right, problem number 2. A restaurant offers the following limited lunch menu. It says for your main courses, you got turkey, spaghetti, meatloaf, shrimp, hamburger. Well, how many choices is that? Count it up. 1, 2, 3, 4, 5. So for my main course, I got 5 choices. Okay. Vegetables, it says you can have pea, squash, cauliflower, eggplant. So again, how many choices? 1, 2, 3, 4. Then you got beverages, coffee, tea, or milk. So that's 3. Desserts, ice cream or brownies. That's 2. So down below it says how many different lunch combinations are there. Again, because I have 4 groups, all I'm going to do is multiply all my choices for each group together. So I'm going to take 5 times 4 times 3 times 2, because that's what the fundamental counting principle says. Take each group and multiply all their number of choices together. So 5 times 4 times 3 times 2 equals 120 different lunches. It's that easy. I promise you, there's no catch. You just got to think about what's going on with the problem. What is it asking? Okay. All right. Question 3. Now, this one's a little different. It's a little weird. Okay. Because you are taking a choice test that has 5 questions. Okay. Notice there's your categories right there. You have 5 questions. So question 1 has its own set of options. Question 2 has its own set of options. Question 3 has its own set of options. You get the picture. So you have 5 questions. And it says each question has 4 answers, with one of them being correct, of course. So it says if you select one of the choices for each question and leave nothing blank, in how many ways can we answer the questions? So again, as we said, you already know what your items are. You have question 1, or your groups. You have a question 1, you have a question 2, you have a question 3, you have a question 4, you have a question 5. These are like our groups. This is like shirts, pants, socks, shoes, earrings, things like that. Okay, those are the different groups, even though it seems like they're all the same group, but they're not because they're all different questions. Okay, and how many ways can I answer question 1? Well, there are 4 ways to answer question 1. How many ways can you answer question 2? There are 4 ways for that one. In question 3, there are 4 ways. In question 4, there are 4 ways. In question 5, there are 4 ways. So to get my answer, all I have to do is multiply all of those 4s together. So 4 times 4 times 4 times 4 times 4 gives us 1,024 different, I'll just call this test answers or ways to answer the test. But there you go. That's how this problem works. Each question was like its own group, like a main course, a side, a drink, a dessert, an appetizer. Okay? Again, there's no catch. It really is this straightforward, I promise you. All right, question 4. A sales representative can take one of 4 different routes from city A to city F, and any one of 6 different routes from city F to city G. How many different routes can she take from city A to city G going through city F? So she wants to get from A to F and then from F to G. There's your 2 groups. How many ways can she get from A to F? There are 4. How many different choices does she have for F to G? There are 6. All you got to do is multiply those together. And if you multiply those together, you get 24 different routes. Okay? And then last but not least, question number 5. This is an interesting question, especially since, we're talking about all the different types of numbers that are possible in the United States. So it says telephone numbers in the United States begin with a 3-digit area code, followed by 7-digit local telephone numbers. Area codes and telephone numbers cannot begin with a 0 or a 1. How many different telephone numbers are possible? So again, up here, it says that all telephone numbers begin with an area code, and then you have 7 digits to follow. Those are what telephone numbers look like. Okay? Notice there are the different groups that you have. Now, here's one thing you have to be careful of. It said area codes and the local telephone numbers cannot begin with a 0 or a 1. No 0 or a 1. So let's go through and talk about how many choices we have for each digit, because that's what they want. It's just like the problem with the test. Each question was its own group. Each digit of part of these phone numbers is its own group. So how many digits are available for position 1 in the area code? Well, you take out 0 or 1, and that leaves you with 2, 3, 4, 5, 6, 7, 8, 9. So that's a total of 8 digits. How many digits are available for position 2 in the area code? Well, you can have any digit you want from 0 all the way up to 9. So that's 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Position 3, again, you have 10 digits. Position 1 and the local phone number. Again, 0 and 1 are thrown out, so you only have 8. The rest of these digits, you all have 10 options. And this right here, if I take all those numbers and multiply them together, that's how many United States telephone numbers are possible. All I got to do is multiply all these. So we're going to go to our calculator. We're going to take 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10. It's a lot. And it's going to be a big number. This is, we're talking about everybody in the United States. 1, 2, 3, 4, enter. So the number of telephone numbers that are possible is 640. Let me count up the number 00. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3. So 6,400,000,000 different phone numbers. Pretty cool, right? The other thing is it is possible to max that out, but because that we have mortality rates here in the United States, again, as people pass away for whatever reason or another, Corona, as people, pass away, numbers become available again. So even though this is a very finite number, just remember that we have people that are too young to have phones, and we have people that are passing away, and their numbers now become available and things like that. So there you go. Kind of interesting, kind of talking about, what's really possible for us. All right. And that is 11-1.